Hi everyone, and welcome to today's live webinar, The Changing Landscape of Wi-Fi QoE. My name's Margaret De Silva. I'm a content developer here at Incognito, and I'll be your moderator for today's session. Today, we're going to hear from 3 speakers about how service providers can leverage the latest industry standards to improve Wi-Fi quality of experience for subscribers. So before I get going, I'd like to just run through some really quick housekeeping items. This is a live webinar. It is being recorded, and it will be available for on-demand viewing. So you will all have access to the slides after the webinar. Since you've already registered for the webinar, there's actually nothing you need to do. We'll send you an email after the webinar, letting you know when the recording and slides are available. So just keep an eye on your inbox for that. During the webinar, there's going to be some interactive poll questions. These questions will pop up on your screen and prompt you for an answer throughout the session. You just have to select your answer from the drop-down list and hit submit. You'll only have a short amount of time, about 15 seconds to answer, and then the results will be displayed in real time. So please do remember to click on the poll question if you'd like to participate in that. And if you have any questions for our speakers today, you can submit them in the chat box located on the left-hand side of the window. We're going to try to answer as many of your questions as possible today at the Q&A session at the end of the webinar, so please don't be shy. Finally, we'd love to hear from you on social media too. Follow us on Twitter at incognito_SFWR using the hashtag Wi-Fi QoE. So I'll take you through a quick rundown of our speakers today. If you have a look at our agenda, we're going to be covering 3 main topics: the landscape of Wi-Fi in 2016, a deep dive into TR69, and wireless operational practices for cable providers. I'd like to just introduce you to our 3 speakers before we start. Our first speaker today is Chris Bush. He is the Chief Innovation Officer at Incognito. Our 15-year veteran of the telecommunications industry, Chris drives the development of innovative solutions that help service providers increase revenue and enhance the subscriber experience. Chris will be speaking about the landscape of Wi-Fi in 2016. Our second speaker today is Pete Coate. He's the Chief Technology Officer here at Incognito. Pete defines the strategic agenda for products, identifies functional requirements of customers, and contributes to industry standards. Pete has a background in OTT, network infrastructure, provisioning and service delivering, and Pete's going to take us through a deep dive of the Broadband Forum Standard TR69 and how that relates to Wi-Fi QoE. Finally, our third speaker today is Steve Harris. Steve is joining us from SCTE, known internationally as ISBE, where he's the Senior Director of Advanced Technologies. A subject matter expert in the telecommunication and information technology industries, Steve develops curriculum, certifications, operational practices, symposiums, and other technical resources at the SCTE. He's going to talk about wireless operational practices for cable providers. So now that you've heard a bit about our speakers, I'd like to pass the mic over to Chris to kick off the discussion about the landscape of Wi-Fi in 2016.
Thank you very much, Margaret. And again, welcome everyone to our webinar on Wi-Fi QoE. We'd like to actually begin this very first section with a brief audience poll. Just quickly, 10 seconds if you could kindly. Have a look at the question here. Will deploying Wi-Fi QoE tools be a priority on your network in 2016? If you could just quickly give that a moment to have a look and go from there. We'll have a look at the results. Seems we've got an overwhelming success rate of results. So brilliant. Perhaps we're right on topic with respect to our conversation here today. So if we look at the landscape of Wi-Fi here this year and in the coming next 1 to 2 years, this really is driven from the innovation in Wi-Fi overall, the surrounding services that are carried by Wi-Fi connectivity. These 2 topics are intertwined, and they continue at a very fast pace for good reason. It's currently estimated that some 4 billion non-802.11ac devices actually exist worldwide today. And some number greater than 6 million new Wi-Fi devices are actually shipping each day into the world. So this places an enormous pressure, when you think about it, on available bandwidth and driving the need for more intelligent use of Wi-Fi spectrum, both in terms of legacy devices and for the next new wave of Wi-Fi device standards. For example, the opening of white space TV spectrum through 802.11af and the soon-to-be ratified 802.11ah, these both are providing new sub-1 gigahertz frequency options to the market. Just as we begin to mature the use of dual-band concurrent home gateways, now we're evolving into even more advanced gateway services. So early automation and home management devices in what we really could call the pre-Internet of Things time period used a mixture of radio technology, often in similar bands as residential Wi-Fi. And this tended to create a noise floor concern. So energy efficiency use and narrow low power carriers for these low bandwidth IoT use cases, such as sensor networks and home automations, may actually bring another new wave of devices onto the consumer Wi-Fi networks in really significant numbers by the end of the decade. So a number of operators, as a result, and vendors are working together towards adding control to the subscriber Wi-Fi network. This has sparked a lot of interest in extending content such as self-organizing networks and radio resource management techniques to residential consumer Wi-Fi. For example, we now see 802.11k and 802.11r, which are radio resource management and fast transition capabilities, being exposed into some of the most recent advanced DOCSIS Wi-Fi access points that are now shipping. So vendors, operators, and standards teams are collectively working to expand the scope then of our available data models around remote management. These include a family of Tier 69 standards, as well as vendor-specific methods, implementing more and more through disruptive and highly scalable cloud architectures. As we'll see from today's conversation, there are aspects of self-organizing networks that actually are achievable using a combination of Tier 69 and SNMP protocols alongside industry and vendor-driven object models. Combining each of these trends begins to form an image of a future for residential Wi-Fi with more addressable spectrum, which means more available bandwidth, a more efficient Wi-Fi network, and one that is supportive of the massive IoT demands to come, and therefore a more intelligent Wi-Fi network that's moving from a conversation of provisioning and into trending and onto autonomous quality and policy capability. So in the cable industry today, we've obviously seen an incredibly fast take rate of Wi-Fi among worldwide subscriber base. The number of tablet and mobile devices introduced from the consumer electronics space is truly incredible from that worldwide base of 4 billion devices we just mentioned. And again, not one of these devices comes with an Ethernet cable. Now, compounded by the embedding of Wi-Fi within the cable DOCSIS gateway, operators are seen now as the go-to for all matters of support, from connectivity to quality, across an incredibly diverse base of unmanaged consumer devices. The quality and support of Wi-Fi really is seen as a direct extension of the cable operator's brand in the marketplace. Let's look at how we typically deploy CPE in the cable space today. This first line at the top is essentially our current state now, and this is simply discussing the most common deployment scenario of a single cable modem gateway with an embedded Wi-Fi access point. Coverage, channel crowding, and general quality issues have driven the market to introduce new generations from the single 802.11bg gateway and further adding Wi-Fi extender products to the mix. Many of these devices, thankfully, are managed, and some devices deployed beyond the gateway, however, are not, and something that we'll be talking about today. The new customer gateways, the evolved ones that we're shipping late last year into this year, are usually dual-band concurrent, capable, multiple radio devices. Extender products may be added that could be bridging devices or even routers. And now the demands really of Wi-Fi are shifting to include IP set-top boxes in addition to the mobile, tablet, portable consumer devices. So if the operator is looking to deploy IP video set-top to the consumer, for example, and that set-top connects over Wi-Fi as its distribution network in the home, how does the operator manage this extension of the network while ensuring quality of the video delivery and not penalizing the other IP traffic from, say, all the unmanaged consumer devices that also exist? Often to guarantee Wi-Fi coverage, an extender device becomes the second operator managed device from the high-speed data service perspective. Well, this now presents challenges in terms of installation practice, in-home CPE wiring to the gateway methods, and remote management. However, the evolution really of the CPE doesn't stop there. Advanced multiple transmit, multiple receive, dual band concurrent gateways with MoCA or with wireless mesh or some other form of backhaul to offer managed Wi-Fi access points delivering IP video, for example, as another new managed service, is fast becoming the next big Wi-Fi install to get right the first time, thanks in no small way to back office provisioning and management systems that enable these new service scenarios. So the mixture now of services in the consumer premises, again, all of these as IP services over Wi-Fi, are their own challenge. Again, for the operator deploying IP video set-tops to the customer, and that set-top is connecting back over Wi-Fi as the distribution network in the home, how the operator manages this new extension of their network, ensuring quality of the video delivery, visualizing the customer topology, and again, not penalizing the other IP traffic, is key to the industry over the next 1 to 2 years. So another aspect in our discussion on Wi-Fi and QoE is the customer care relationship. Either through an assurance tool's inability to root cause, diagnose issues, or perhaps a combination of customer-induced changes to their premises network. When we talk with a number of operators worldwide, it seems the main indicator of call resolution is reset password or reset gateway. This generates a tremendous cost to operators who often cite in terms of support call volumes that they hear from each and every one of their subscribers at least once in terms of the total annual call volume. And that, of that raw number, usually over a third of calls, if not higher, are a Wi-Fi problem related, and again coded with a resolution of reset password or reset gateway. Having these calls is itself a cost to the business, but worse is dispatching field technicians for intermittent Wi-Fi conditions as can also occur. So clearly, basic Wi-Fi connectivity issues could be more easily understood in terms of remote support. A Wi-Fi device that's failing to connect given poor signal quality or incorrect network selection or password, these are likely being resolved, so to speak, by that remote reset of the gateway or by turning the security off when the subscriber tries to join the device to the service. Many access point devices, however, they don't expose client connectivity failures. Now, this would be valuable data to poll a device for in troubleshooting such connectivity in real time while the CSR representative is having a conversation with the customer. So as Pete will discuss, existing Tier 69 standards enable visualizing the CPE topology and offering a dashboard display of connected devices by SSID or Wi-Fi network. For certain more modern gateways, this may also include indications of the network bandwidth that's available over Wi-Fi and potentially noise level that's present in the operating channel. Troubleshooting quality, however, is a much different art with our current standards. The Wi-Fi gateway can be polled using SNMP and usually Tier 69. For many, Tier 69 is the preferred choice as it's also capable and really the key enabler of visualizing the extender and other managed devices beyond the gateway we discussed a moment ago. The data offered through either protocol and various data models, however, is only as good as the last poll. So building this data up over time and narrowing the interval time between polls is an important subject to build key indicators of Wi-Fi quality of experience for the subscriber. So it's clear then that Tier 69 and to some extent SNMP will be with us for some time to come. where broadband gateway and Wi-Fi service management are concerned. One of the forward-looking changes will be the cloudification, if you will, of these standards and the introduction of additional radio and network control plane protocols such as COPE or CAP-WAP, or even publisher subscriber message bus type technologies based on the Tier 181 data model that comes to us from the broadband forum family of Tier 69 standards, any of which may form part of an overall Wi-Fi management strategy. Clearly, operators are asking more and more of their ACS investments. Obviously, these platforms possess the single largest and most meaningful data model where residential Wi-Fi is concerned, given the Tier 69-based ACS is at the heart of provisioning and monitoring all of our deployed gateways. However, these systems are only as useful as that last inform interval, the last time we talk to the device. And so in some respects, you could close down that interval for Tier 69 data to be reported by a gateway maybe even just 60 seconds. It's a very aggressive rate. So could we do that? Well, the concern being at this level, you actually may be sending more management data at times than actual data being used by the customer. As increased load demands appear then on ACS platforms themselves, the disaggregation of ACS technology into cloud architectures will actually support our future scale-out demands here. For what's clearly needed will also be a quasi-intelligent gateway, some co-resident agent working alongside Tier 69 inside the CPE device in terms of management and provisioning to report on real-time RF status, in addition to new control plane protocols offering network control alongside of device management provisioning. Only when these key elements are combined do we really begin to form a position from which subscriber quality of experience over Wi-Fi can be realized. So with that, again, I thank you for your time. I'd like to hand it over to Pete Cote, our CTO, to take us further into TR69. Pete?
Thank you, Chris. I'm Pete Cote. I'm the Chief Technology Officer at Incognito Software. I'm going to be highlighting some of the technical options available to service providers to help detect and identify potential service issues, how to proactively resolve these issues to avoid upsetting the subscribers, and how to uncover business intelligence that operators can gain through proactive monitoring and management of Wi-Fi signals. Before we start, I'd like to start with a quick poll. And the question that I'd like to pose to the audience here is, are you currently actively leveraging data through Tier 69 to improve your customers' Wi-Fi experience? Take a quick moment to vote before we continue on. See that we have a similar number of responses, so I will continue on at this point. Thank you. I think everyone on the line would agree when I say that subscribers today expect to be connected at all times with exceptional service quality. The modern connected environment, both in residential and commercial setups, rely heavily on wireless connectivity. As Chris mentioned, the number of tablet and mobile devices introduced into the consumer electronic space is over 4 billion devices, none of which have an RJ45 plug. The experience the consumer has on any wireless device is directly attributed to the service provider, regardless of Wi-Fi interference or low negotiated speeds. Every time subscribers voice their complaints in a public forum, even when the issue has nothing to do with the operator, the image and credibility of the operator suffers. To that end, we have seen a proliferation of access point extenders deployed, be it through HomePlug, MoCA, or an off-the-shelf consumer extender. The Wi-Fi standards have been evolving over the years to include the use of dual-band spectrum for higher throughput, and has been continuing to evolve for the IoT world in the sub-gigahertz range with the energy-efficient, burst-friendly 802.11aH. The challenge that operators have today is that the network topology associated with wirelessly connected devices, be it in a home or a multi-dwelling unit or part of a commercial environment, is getting more and more complex. This complexity is contributing to signal interference and is unnecessarily consuming copious amounts of time for the CSR, whether they're troubleshooting why Netflix isn't playing smoothly on an iPad or attempting to figure out why new devices won't connect to the home Wi-Fi network. Worse yet is the eventual truck roll to determine how to solve these Wi-Fi problems, which happen often in densely populated areas due to high level of interference. But not all is lost. Most modern access points provide a rich data set, either through existing TR69 or pulled using SNMP. This will give a temporal snapshot of any pertinent data points useful in establishing a high quality of experience over Wi-Fi. Aggregating that data, performing trending analysis, and establishing heuristics will play an important role in establishing automated business processes that will work to improve the overall Wi-Fi quality of experience for the end customer. Let's take a look at what's available under the hood specifically with TR69 and related broadband forum TR181 data model. I want to focus on how you can leverage specific Wi-Fi related attributes to build key performance indicators that identify high-risk subscribers on your network, and how to proactively optimize your subscriber's Wi-Fi environment before it results in a support call and the eventual truck roll. The first place to start would be to evaluate the data available using TR181 data model and potentially vendor-specific extensions. To identify the access point, we have access to the BSSID, AP MAC address, the SSID. Interesting Wi-Fi QoE attributes available via TR69 includes the number of radios, supported bands and channels. And under spectrum management, specifically 802.11h, which was to solve 5 gigahertz coexistence with satellites and radar, we have the received power indicator, the RPI histogram, the clear channel assessment statistics. And under spectrum utilization, we have visibility into the number of retransmission errors, bytes or packets that have been sent, received, and dropped. And for the configuration settings, we have access to the security, none, WEP, WPA, WPA2, and its variants. It's also interesting to note that many access points still have no protection whatsoever or are using an easily hacked setting. We have visibility into the encryption mode, the frequency band, 2.4 or 5 gigahertz, the standards used, ABG and AC, and that was reflected in Chris's first slide highlighting the Wi-Fi landscape. Also important to note is the basic and supported transfer rates, which means that the AP will only permit connections at those available speeds. Leveraging this data will give an operator a lot of information to start with. Using this information, operators get a glimpse into Wi-Fi difficulties on the access point. To get an even clearer picture, many access points also expose information related to the neighboring APs, which could be creating spectral interference affecting the noise floor. Using this information, operators can start to optimize their customers' Wi-Fi cloud to improve their quality of experience. Now, similar to the base station itself, the operator can potentially see a lot of information from the neighboring APs, particularly the identifying attributes are very similar to the local AP settings, where we can see the neighboring access points, BSSID, the network name, the mode. And looking into the neighboring attributes, we're able to see the current radio channel used, the average radio signal strength, the RSI, over the last 100 packets received. And similar to the local AP, the base station is able to glean security and encryption modes used on each neighboring AP. Additionally, it's able to see data transfer speeds available, frequencies employed, and standards employed. Now we're starting to see a clear picture of competition for signal integrity. But competition is not necessarily a bad thing. 802.11 was invented with coexistence in its DNA. A heavily contested channel on a 2.4 gigahertz spectrum isn't necessarily a bad thing, especially if there are no drop packets or low negotiated speeds. Let's take a look at what TR69 gives us for the connected devices to the AP. This is where we start to finally get a clear picture of whether there is a problem and how to optimize the user experience. The access point, seen near the middle of the slide, gives us a wealth of data to identify the devices and monitor the quality of experience. Critical data for the CSRs when fielding a support call related to slow connections over Wi-Fi. We're able to see the MAC addresses of the connected devices, the DHCP lease info, and combined we're able to leverage that data to essentially determine the manufacturer and the type of device. The attributes are very similar to the earlier two I discussed. The signal strength, the RSI, the number of bytes sent, received, and dropped, and the number of retransmissions. There are many other attributes that can be gleaned from vendor-specific extensions that improve the granularity of the Wi-Fi picture, visualizing the topology at the subscriber premises in a simple dashboard. Taking that ephemeral data and putting it into a data warehouse enables the operator to actively mine Wi-Fi statistics for proactive care purposes, to implement, launch, initiate, and deploy network-wide KPI metrics with trended patterns, essential tools for the operator to provide proactive care before a subscriber becomes disenfranchised. So how can we use that data to optimize the operator's Wi-Fi deployments? There are two major usage scenarios that are critical to an operator, which we'll cover today: the single AP, residential or commercial, and the MDU. In the case of the single access point, which assumes there is no Wi-Fi extender, the challenge is usually quite simple. There are two major courses of action for improving the subscriber QoE. Bind to the channel with least interference. Looking at the following ACS Wi-Fi site survey, you can see in the 2.4 gigahertz spectrum, a better choice would be to operate on channel 7 or 8. While in the 5 gigahertz spectrum, channel 42 would have been ideal. This could be extended into a self-care option, which would use this business intelligence to automatically optimize the settings in the network. The second area to focus in on would be the connected devices, in particular, looking at the negotiated speeds, the number of retransmissions or drop packets as a facet to determine whether a conversation regarding Wi-Fi extenders is in order. Similarly, it's important to determine if there is a particular device or groups of devices that are consuming high amounts of bandwidth within the home. This is particularly useful in a CSR call to validate that the consumption rate is a target percentage of the provision speed. Scaling beyond the single AP is a conversation about MDUs or community Wi-Fi. And here we have a larger data set to analyze, correlating BSSIDs with known subscribers, and in effect, providing a means to programmatically enable a granular self-organizing network which is able to take action on device settings to improve the overall quality of experience for all. Beyond signal quality, the data available provides the operator with valuable business intelligence that can be leveraged to automate rules in an ACS to improve customers' experience and maintain your brand. With better trending analysis, you will be able to see through the complexities of a modern Wi-Fi cloud to intelligently determine how customers' experiences can be improved, whether that's by replacing a single band AP with a new dual band gateway, deploying Wi-Fi extenders, either managed or otherwise, or merely providing Wi-Fi as an optimization tailored to neighborhood conditions and local topology. One thing is certain: today's gateways provide a wealth of business intelligence. Learning how to capture and utilize that data is paramount to optimizing the Wi-Fi quality of experience. I'm going to pass it now on to Steve.
Thank you, Pete. Appreciate that. I want to share some of the work SET has been doing with the industry, with our vendor partners and our cable operators, and how this benefits the quality of experience. Also, we're going to look at some examples where the tools can be leveraged to improve that quality of experience that we're all looking for. So the SET and ISBE as our, and ISBE being our global brand, we've been developing standards in over 300 different areas for the industry. But you may not know that we also develop operational practices. And the idea with that is providing guidance in particular technologies, such as wireless, and then among other standards, such as IPv6 in the cable industry. We did this to help with the issues like Chris and Pete have mentioned. It's trouble with resetting passwords and gateway, and also trying to help operators reduce those truck rolls. So what is the SET Wireless Working Group? Well, this is a group, it's a cross-section of the industry made up of the top vendors in this space, along with all major MSOs, and in particular folks from Canada and United States. The group provides characterization of the wireless networks such as Wi-Fi, And what we're really looking at, including the RF propagation, the data rates, client performance, things that Pete and Chris have shared with us, along with provisioning and some of the top issues seen by operators. We also are looking at how the MSOs and vendors are measuring the quality of service along with the quality of experience, along with how do we survey the environment for wireless. And that's in particular where we're looking at not just the 2.4 and 5 gigahertz space today, but in the future we're going to be looking at the 900 megahertz space in 802.11ah, and also maybe looking at other RF spectrums that Chris mentioned earlier, such as 802.11af. And then moving forward, we might even be looking at the 60 gigahertz space, 802.11ad. But this is important to identify these interferers, especially as we move beyond just our standard tablets and smartphones in the wireless, and we start including the wireless set-top boxes and other clients, but also think of new things that are coming into the network, such as Internet of Things and machine-to-machine communication. So what we do is we pull all these topics together, and we develop an operational practices that cable operators, along with our vendor partners and our global members, can use to improve the quality of experience. And finally, the customer education recommendations are important as well, because Wi-Fi is a technology that is not well understood. And probably one of the reasons and that SET has developed training around it and has developed operational practices in this area. So what are the core wireless needs of operators? Well, we know that operators are always interested in offering new services. And those new services that we've been talking about is in the area of managed Wi-Fi. We really want to improve that experience by owning the Wi-Fi ecosystem. And what that means is providing a system with an intelligent gateway that allows MSOs to control the experience and target issues impacting quality of experience. We also want to improve coverage and range. We want, as Pete mentioned, an autonomous access point operation. We want this to happen without us intervening each time we have an issue within the home. And as we move to 5 gigahertz and other 802.11 technologies such as AD, we want to make sure that we provide the same quality of experience as we move into Ultra HD video consumption. We also want to make sure that experience provides for the extending of Wi-Fi networks in a way that also improves quality of experience. Now, managing the Wi-Fi network improves retention of our cable customers, whether it's in-home or within community Wi-Fi places. It also reduces calls, which are very important to our customers, and that's calls into our customer service departments for password issues or RF issues or environment concerns. Operators also want a carrier-grade Wi-Fi home network, and whether that's in a home network or in a hotspot environment. That means it's one that's not best effort, one that allows multiple HD streams today in video and multiple Ultra HD tomorrow. We want to extend the visibility and the topology view for the cable operator and performance monitoring. The network will evolve as it keeps changing with machine-to-machine, Internet of Things, new devices. So we want to make sure that we keep looking at those KPIs and provide the best quality of experience when it comes to Wi-Fi. Let's take a look at a poll question here. If you could kindly please make a selection. What we're looking for is which is the most common Wi-Fi issue you're experiencing? Is it the lost credentials? Configuration? Could be range and coverage. Now you can only pick one. Slow or low speeds, intermittent connections. So if you had to pick your top issue, which one would you pick? I'll give you another few seconds there to chime in. I think I see a couple more people. All right, give you a little few more. All right, I think we have what we need there. Let's see if we can pull those results up. So it looks like slow or low speeds is tied with range and coverage. Let's talk about some of these issues that you're experiencing. So if you take a look at those quality of experiences issues, we kind of broke them out here for you. RF propagation, which you everyone on the call seems to agree with is one of those top issues. Whether it's the hardware that is providing that Wi-Fi service as we talked about, and that hardware changes, right? We're now into 802.11 AC second wave. Coverage, and it depends on frequencies. We know that higher frequencies attenuate more, maybe the interest in the 802 AH and AF ranges. Range is an issue, and also channel selection. And having these things happen in an autonomous way is very important. Customer education is important. Where do customers use Wi-Fi? It's very important that we have proper placement of equipment in these locations where Wi-Fi will be consumed. We also want to classify and understand old and new clients, like Pete was discussing with TR 181 and TR 69. Very important that we understand those clients, and especially as we move into different frequencies. And also we want to know when hardware is being relocated. Also usage, limiting users or services. I'm going to show you an example where we can very easily overload new technology. So sometimes new technology is not the solution to your problems with quality of experience, unless we also address other issues associated with that. Also, upgrading technology may support some of your challenges, maybe a tiered quality of service, or even using new mechanisms like band steering. Data, we've already kind of covered that with Pete and Chris, but data is very important, these Wi-Fi analytics, and leveraging the TR, Simple Network Management Protocol, and IPDRs. All important areas. So here, what are some of the areas that we can improve these quality of experience issues? Well, manage Wi-Fi. Controlling of the subscriber's ecosystem, making it more reliable, moving away from these best effort networks that we were talking about. Making roaming a real option for subscribers, leaving tools or leveraging tools like MoCA and RF extension. And we saw that leveraging more data from our devices using 802.11u, making it allows it easier access with auto network discovery. Wi-Fi Alliance Hotspot 2.0 and Passpoint. Moving to a carrier-grade version of the network. And of course, leveraging new technologies such as 802.11ac. Now, in this example here is just kind of showing us where we can grab more information. So it's essential that MSOs can pull data to improve that quality of experience and learn about their Wi-Fi networks. As mentioned earlier, TR69 can share a wealth of information. And this provides that visibility that's a concern for us today. We want visibility all the way, in some cases, to the hand where you're using that smartphone. So here's an example of discovery process used for IP multimedia subsystem. Now this is an interface that allows MSOs to offer voice over Wi-Fi following the third generation partnership project. The main point here, it requires a solid managed service where these services can flourish. And it's important that we glean information out of the Wi-Fi network. Here's another example, talking about a boost in technology. And obviously, probably nothing much here on this slide that you don't already know. But you can provide better technology to the customer to improve that experience. But in many cases, managing the experience allows for extended life cycles here. So it's not always changing out the equipment to solve all the issues. And then this example is showing a boost in technology where I've deployed 802.11ac, and you can see that even though I have new technology located in this example, you can see still heavy loads. If we don't manage those, we could still have decreased reliability. So if I can kind of highlight that for you. Heavy loads, it has increased call setup, and this is all for voice over Wi-Fi. And you can see it still affects speech quality. So even though we have the latest technology, we haven't solved the issue, right? And my final comment here is just kind of sharing some of the wireless resources. So everybody's hungry to learn more about wireless, and we have a lot of resources as an SCT member you can leverage for free, whether it's a live learning or tech webinar series. We have a dozen webinars that cover Wi-Fi experience, carrier-grade Wi-Fi, and many other topics. We have online and on-site training the SCTE is a certified wireless network professional partner, and what that means is that we offer cableized versions of their content, so that you can now become certified and also learn all the ins and outs of wireless to make your teams more productive in this space. So now I'm going to turn this back over to Margaret.
Thanks so much, Steve. Well, look, we have a few minutes for our Q&A, and we have some questions coming in already. But on your screen, you'll see the final poll question. Now, if you could take a minute just to have a look at that while we queue up our questions from the chat. So the question is, what feature is most important for a Wi-Fi service management solution? Visibility into the customer network, visibility into Wi-Fi bandwidth, failed device authentication alerts, Wi-Fi optimization neighborhood scans, or all of the above? I'll give you a couple of minutes just while we get those questions up on our screen, just so you can answer that. Now, so far, looking at it, almost overwhelmingly all of the above from the people that have participated. Give you a couple more seconds for that. So it seems that pretty much everyone so far that's participated thinks all those issues are important. That's great. So we have a few minutes left. I don't want to take 81% of the people that participated. But we have a few minutes left for question and answer time. I don't want to run it too far over, so I'm going to field a question each to the presenters. The first question I've got here, I think, Steve, you might be able to answer this one. Where is the cable industry right now in terms of adoption of TR69? I'll turn that one over to you.
That's a great question. The cable operators are really looking to turn their best effort networks into more of a carrier-grade network, and to do that, it is leveraging TR69. We realized that we can no longer allow the customer to manage their network. We have to own the Wi-Fi ecosystem. And what that means is we have to leverage tools like TR69 and TR181 to get that visibility into that customer's home. And the visibility that Pete mentioned earlier is not just the gateway, but the devices beyond the gateway. So I would say, in summary, that all cable operators are looking and moving in this direction, and in some cases have implemented TR69 already in their Wi-Fi networks.
Okay, great. Thanks for that, Steve. So I've got another question here. I think I might give this one to Pete. It's to do with visibility into the home network. I guess why do you think it's important for the operator to get this visibility and understand this network topology?
Thanks, Margaret. That's also another really great question. Visibility into the topology within the home is important for operators to deliver proactive care solutions that autonomously improve Wi-Fi settings. Steve mentioned leveraging band steering. Now, this allows the operator to move away from a best efforts to a high-performant managed network. And this data provided with TR69 or pulled through SNMP is also paramount for efficiently resolving Wi-Fi related CSR calls.
Okay, thank you, Pete. And I guess we probably have time for probably only one more question. Chris, I'd like you to answer this one. You spoke a bit about the cloudification of the network. I guess when is cloudification likely, and how will it impact service providers, do you think?
So another great question. This is another fast-moving conversation in and of itself. I think for a lot of folks, we've seen some operators who have been making investments in, if you will, the private cloud or the operator cloud, as it were. And so it's a bit of a conversation of sort of modernizing how operators are deploying their compute resources, achieving effectiveness in the spend that they offer today in budget processes to available compute and back office platforms, and that's starting to intersect with the real demands of OSS applications engaged with the edge device themselves. So where TR69, where ACS fits into that is exactly right in the middle of that statement, where just as we're beginning to rely more heavily, as Steve mentioned, to create a carrier-grade system of delivering the promise of Wi-Fi, we're doing it with a lot of carrier standards, right, with broadband form-based methods that are going to need the horizontal scale-out that comes from a cloud compute and cloud orchestration back-end design. So it's really sort of the next new thing that's upon us to be able to scale up and scale out what we need over the next two years and beyond around Tier 69 technologies where we're delivering Wi-Fi quality is concerned.
Okay, great. It's really interesting to hear the future of where that's going. Well, it has been 45 minutes, so I am going to have to, unfortunately, wrap it up. Thank you all for your insight, Chris, Pete, and Steve. Unfortunately, that's all the time we have for today. So if anyone on the line has further questions, feedback, or even suggestions for the next webinar, you can tweet us at incognito_SFWR or email us at events@incognito.com. Once again, thank you everyone for joining us today, and thank you to our speakers for leading the discussion. Have a great day.